Hello everyone and welcome in a new video. In this video, we are going to understand a concept of multi-threading. Okay, so let's start. So what is for understanding the multi-threading, first of all, we need to understand about the thread. What is a thread? Let's take an example that what happen if you are if someone ask you if someone give you a task to performing same thing again and again and again. So what happens? After one point of a time, you will be exhausted and you will be burst out. Simple. So these what happens if you are doing the same thing again and again and again, you will be you will basically burst out. Okay. The same thing happen in the system as well. So if you are if let's give an example of let's this is what a Google search is. This is what a Google search. Okay. So what is happen is you are searching a thing. Okay, you are searching a thing. For example, you are searching for a dog. You are searching for a cat. You are searching for an elephant. Okay, so what basically they do rather than to making a process for the dog one, making a process for a cat one, making a process for a elephant one, what it do because after one point of a time, all the task is what skip. We put an input, it goes in a register take to the code, and then it's searching in a code. So this part is basically what same for the every search. Okay, so what rather than making a creating a process a new process again and again and again for the every search, so what happens? System has become slow. A lot of problem basically arise if you are running same thing again and again and again. Memory is basically increase, and so many problems is basically arise if you are performing the same thing again and again and again. Okay, so many problems is basically arise. So to overcome these problems, what basically happen is we are creating a thread. What we are going to do is we are creating a thread. Okay. It is faster. It can create you out. What happen if I making a process for the dog? This is what a CPU. Okay, this is what a CPU. A dog process you search. And in CPU, what basically happen, you execute and you will get a result. You will get a result about the dog. And then again, it create a process. It create a process. Let's say this is what Q P1 process about the dog. Then we are creating a cat process. Then we creating a elephant process. So for every search, if we create so many processes, it creates some effect. So what causes what basically it causes? It basically the system becomes slow because we have so many processes. So if you execute these processes, your system will become slow. Okay, so there are a lot of problems. Communication gap can taking place. There is a resource. There is not a resource share. There is a basically not a resource sharing concept. Means like if you put one thing and then put another thing means your resource is basically over up. Okay, so to overcome these problems, to overcome the repetition problem, the same thing repetition problem, there is a concept of thread. What it do, it create one process. It let's say it create a process. This is what a process is. It create a process. So whatever thing is common for every process, it store that process in a block. It store that thing in a block. Like this is what a block. So this is what a block. Okay, so the important thing basically is stored in this block. What are the important thing for a process? Every process having its code segment, its data segment, its heap, its stack. So many things is there. So many things is there. So what basically it does is it store that thing in one point in a particular point, and then whatever the task is. So P1 is like search for a dog, P2 is like search for a cat, P3 is like search for an elephant. So whatever the important thing is, whatever the new thing is, basically get search. Okay, so what we do, we create a thread of these process. Now it's overall a one process. This is not a process. This is not a process. Now it's a thread one, thread 2, thread 3, and it's overall this whole thing is now become a process. It whole thing now become a process rather than creating so many processes, because every process have its own heap, on its data segment, on its stack, or on its a code segment. So every process have these things, so it create a lot of space. Okay, so rather than doing that, we do this thing. Okay, so there is one point. So if let's say thread 1 come and get a CPU, execute, and then terminate. Okay, so what happen if we create so many threads? So the system is become really fast. System has become really fast because everything is there. So no need to fetch this again and again and again for the new processes. So CPU get this. So every time when such thing happens, for what's the new thing happen? So we do that thing rather than performing the same task again and again. So this is what a resource sharing is. We share a resource to the other threads. Okay, so this is what thread, the task is what a thread, and the resource. Okay, so what is a thread basically in a simple way? If I told you what is a thread is basically a lightweight process. Thread is a lightweight process because it's only contain the query. It's only contain the query. Okay, it's a lightweight process, or you can say that it's a component of a process. It's a component of process. It's a component of process. Okay, so this is what a thread is. It basically provide you a way to improve the application performance through parallelism. Okay, so what basically thread help you do? It provide a way. It provide a way to improve application, whatever the application you made. In this case, in a Google search, what happened? If it create process again and again and again, at a point of a time, a lot of processes created, so its server can be crashed. Okay, so doing the same thing, what it do, it store that thing in a particular one process. What the it did, it collect, it take only one process. Everything is whatever the common thing is, it share that common thing to all the other queries, all the other threads. It share that common thing of a process. Okay, so it provide a way to improve applications. Okay, so this is what a thread is. Okay, now we say about the resource sharing, we say about the unique things, that these queries are unique, the resource is basically shared. So resource thing is what are common. So what are the common thing, what are the shared thing, and what are the unique thing for the thread? We say that common thing is like code segment, this and that. So what are these things? What are the things that the process is basically shared, and what are the things that thread is not shared? Okay, so shared resource, which is basically stored in this part. Okay, and what is the unique thing which is stored in this part? And collection of this is called a process. Collection of this is called a process. So shared resource and other thing is unique one. Okay, unique for every thread, unique for each thread. What are these things? First of all, which is shared is basically a code segment. Code segment, which is common for all the processes. For the processes, basically, so code segment is same. Means what is a code segment? Like someone search on a Google. So what is the process? It collect query in a register. It search that query in a and basically in its database. It's what is the what how it basically search in a database is the code, whatever the code is. So that code is similar for all the other thread, whether you are search for a prime minister, you are search for an elephant, you are search for a peacock, you are search for anything, that code segment, the searching in a database is basically the same, the code segment is same. So this is what in a shared resource. The next thing is the data section. Data data section is like a global variables. Global variable, whatever you define in a globally, it means what? It means you need to use that thing everywhere. That's only you define in a code, a global variable, so that you can use that variable anywhere. Okay, so if you are using that thing anywhere, it means you are making this thing shared. shared for a one program, shared for a one function, shared for so many functions basically. So the data section is basically shared. And operating system resource is also shared. Operating system OS resource. What does this mean? This means like I'm creating a video. I connect mic. I connect OBS Studio. I connect my pen tablet, and I connected my mouse. So everything is basically connected. Everything is shared. Everything is shared. So OS resource is also in a shared one. Okay. So these are basically a shared one. Okay. So this is what an OS resource is. And what are the other things which is shared? Like the files, the signals like Microsoft Word, Microsoft Excel. So files, open files and signal is basically shared. And what is shared? Heap is shared. Heap, heap. Heap section is also shared. Means sometimes what happen is your stack is full. So it take the space of a heap. Sometimes the code section or whatever the thing is full. So heap what exists table. The section of heap is what exists table for the resources for the storage. So this section is also shared. This section is also shared. Now, what is the unique thing? The everything, because now we have so many things to share. So how we distinguish the queries? So every query is like T1, T2, T3, that's the queries is a thread. So every thread has its own unique ID. Okay, so every thread is having own unique ID. So thread ID is basically not shared. Register set is not shared. Means where the thread is basically stored. If you share that thing, it means you are creating all the queries in a similar way. Okay, so that thing is not happen. A stack, the result should be stored in a for a particular thread in a particular stack, and a program counter. Program count. So these are the thing which is unique, which is not shared, Okay. I hope you understand about the shared resources and a unique resources. What is a unique for the thread? Okay. So I hope it is clear to you that okay. So program counter, whatever the thing you stored in a register, basically in a program counter. So if okay. So one more thing that is you need to know that in a process, what basically happen is we have a PCB, process control block. Process control block. What happen in a process control block? All the detail about the process ID, about the state, about everything about a process is basically stored in a PCB. Okay. Similarly, there is a TCB. TCB. What is a TCB? Thread control block. Thread control block. What basically it stored these things. It stored about everything about the thread, its ID, where it is stored, how it increasing, how it starts, what is it get in return. So everything about that is stored in a TCB thread control block. Okay, so we have a like register set. Register set basically we have a lot of thing in that register set, like the program counter, like the accumulator, like the uh, single purpose register. Okay, like the registers. So we have these thing happens. This thing is basically stored in a register set. So what is a register set basically? What is a register set? Register set is basically the collection of these things. Okay. Now we understand about the unique things, we understand about the shared thing, we understand about the thread. Now we are moving towards the advantages. That what is it? Advantages. Why we study this thing? Why the thread is in a use? You have a process. Why is thread is in a use? What is its advantage? Advantage is that it's the responsive, or you can say responsiveness. Means if some part of a code, let's understand this thing, like this is what a common section. If some part of a code is shared, so if a new process comes, let's say T1, no new thread is come, T1, T2, T3, So it doesn't have to create its own stack, heap, and everything. It doesn't have to create its own PCB. Then PCB goes to the CPU, then execute, and then store the result. So it doesn't have to do these things. It have a very small thing. A query, come execute and get a result. So the responsiveness of a particular application is increases. And what is the advantage? Advantage like it is faster in a context switching, faster context switching or context switch. Process come execute terminate, process thread come execute terminate, thread come execute terminate, thread come execute terminate. There is no heavy thing. It basically take, it's only have a thread ID, a stack, and the register. Come execute terminate, get a result terminate. Come get a CPU execute and then terminate. Whatever the common thing is already is in a place where the CPU is used from there. Okay, doesn't have to create its every process for every PCB. Okay, it doesn't have to create so much PCB. It's only have to create the TCB, which is very lightweight, only understandable, only having a thread ID and there is tag and a register to store the result, to basically identify that with this result of for which query. So it's a very small, very lightweight thing. So faster context switching is taking place. Okay, now what's the next thing? We share a resource. So resource sharing, resource sharing. We share a resource, a common thing. We use a common thing. Try using a common thing. So resource sharing is taking place here, and it's if you are basically creating a one process, not so many things, not the your system, your application is not become heavy. It means what? It's a very economical. It's very economical as well. And the next thing is communication. Everything is communicate in a process can have to communicate with a common thing. And what is a query? What basically need to serve? Okay, so the communication is an advantage, and the utilization of a microprocessor architecture is also an advantage, because you are creating a process, you are not that way utilize that microprocessor in if you are creating a one process and creating a new thread, so you are using that microprocessor in a good way. You utilize it very much. Okay, so utilization of microprocessor. Okay, so this thing is there. Now we understand about the common thing and this and that and everything. Now what we are going to do is we are seeing that which is what's the basic difference between a process and a multi-threading. Okay, what is a multi-threading basically means, in this case what happened, we have only one thread. If we have so much thread, and we say that multi-threading. Okay, if we have only T1, then we can say it's a thread, and if we have more than one thread, then we can say that it's a multi-threading. Okay, oh, now now this is block for the process. Okay, and this is block for a multi-threading concept. Okay, now in a block, we operating system is definitely there. Okay, now what is the thing for having here? Let's say we have a three thread, or you can say a three process for the for this processor. So let's say we have a process. What thing basically happen is code. What happen is data. What is basically get is having is heap. It's having a stack. So many things is there. For the P2, same thing. For the P3, same thing. How heavy this process is. So if a process need a CPU, it create a PCB. PCB, it take time to create a PCB because there is a lot of things, and then PCB goes to the then PCB goes to the CPU. PCB goes to the CPU, and then result is stored again in this heap in this stack. So it means it is a very heavy thing. It's a take a lot of time. It take a lot of effort. Rather than what we are going to do is we are creating a heap section. This is what a multi-threading. So what happen is we have a heap, we have a data section, we have a code section. So these things is basically common, same for all the thread. These all things are same for all the thread. all the thread is same. Okay, what is the new thing? Like T1, the new thread for the process T1, there is a T1 which having only stack, T2 having its own stack, T3 having its own stack, which basically used to store the result, whatever the result that came. Okay. So if CPU want to do what it takes the thread, very lightweight, not have to create the so much PCB, it have to create the TCP, which having the stack detail, having an ID detail. Come get a CPU, execute, terminate, get a result, and then terminate, then T2, then T3. So it definitely becomes fast. So this is what a multi-threading is. So many things, so many threads, and the main thing is what this whole is called a process. This process and this process, P1, P2, P3, and only one process. Thus, the queries are the different only. The queries are different only. Okay. So this is what a multi-threading is, and this is a normal process concept. Okay. So I hope you understand about the multi-threading. Okay. So many threads for the same thing happen. We create a same part. Whatever the new thing is, we perform that thing. Okay. So this is what a multi-threading is. Now, to talk a lot of thing about the thread. Now we have to understand that there is a two types of thread. Two types of thread. We have two types of thread. First one is called the user level thread. User level thread. And the second is kernel level thread. Kernel level thread. User level thread and a kernel level thread. User level thread basically created by the user. User level thread is created by the user. If user create the thread, it means what? It means that operating system doesn't know anything about this thread. Operating system doesn't know anything about the thread. What does this mean? This means you develop a software and making a lot of thread. You develop a software. Let's say you develop this application, or you can say the software. You create so many thread here and you execute this. Does operating system know about this thing? No, because you create that thread. Operating system does not create this thread. So how operating system will know about these things? So operating system does not know about the user level thread. This is a very important thing. You can write it like note as well, that OS does not know about user level thread. Operating system doesn't know about a user level thread. What is basically these thread? Okay, because you create these thread, so operating system doesn't know about these things. Okay, so this is what a user level thread. And what is a kernel level thread? Kernel level thread is simple when the thing was done by when the thread was created by the operating system. So if it is created by the operating system, so definitely it know about these things. Okay, so kernel level thread, user level thread. I hope you understand the difference. Kernel level thread, what happen is in kernel level thread, basically it is done by the operating system. So if it is done by the operating system, operating system know about these threads. So every detail of the thread is known by the operating system. It is created if it is created by the operating system. If it is not, then operating system doesn't know about that. So if it is a user level thread or whether it is a kernel level thread, every thread have its own advantages and a disadvantages. Every thread have its own advantages and the disadvantages. Now we understand these advantages and the disadvantages, and we end up this video. Okay, so user level thread and a kernel level thread. User level thread and a kernel level thread. Okay, kernel level thread. So let's start. User level, kernel level. First point, that multi-threading in user level is created without a kernel intervention, or you can say without the known by an operating system. Okay, so multi-threading multi-threading is basically in a user process in a user process is created by user. So if it is created by the user, so there is no kernel intervention. So no kernel intervention or intervention. Okay. Now the point for the kernel, it is created by the kernel, so kernel does know about these things. The operating system know about these things. So multi-threading in kernel process is created by the kernel itself, is created by the kernel itself. So multi-threading in kernel level, kernel process is created by kernel. So if it is created by the kernel, so it means it is well known. The operating system is well known about these threads. Okay. Second point, context switching is very fast. Context switch is very fast. Okay, because the thread is in a user, so a thread is created by the user, so it's betterment for the software. So the switching between these threads is fast, doesn't have to create the PCB process control block or everything. It whole treated as one process. Operating system basically treat thing as a one process whole thing as one process, so it execute one process rather than creating the threads, rather than creating so many processes for every thread. Okay, so it is fast and it is slow, because if you want to perform the same thing, it creates another process. If there is a new task, new process, whether the task is same or a different, so the context switching is slow here. Next point, that in generic, it can run on any operating system. In general, user level thread is basically run on any operating system, doesn't depend on operating system. But if the process is created by the operating system, a particular operating system, then definitely it is specific to that particular operating system. So it is specific for the operating system. Okay, let's say you are using a Mac. So if you are creating a process on that, then you can able to use that process. And if you are creating a thread, multi-threading, if you do multi-threading on that operating system, then you can able to execute that process in that particular operating system. You cannot execute that thing in a different operating system. Okay, so this is the benefit of a user level thread over a kernel level thread or operating system. Fourth one, if one thread is blocked, whole operating system block. Operating system basically block the entire system. So if one thread is blocked, then what happen is, then operating system block entire process. And here individual thread, so it cannot be blocked. Can be blocked. Okay. It can be blocked. Okay, a particular thread can be blocked, but the whole thing cannot be blocked. What does this mean? What does this mean? Let's understand this thing in detail as well. If you are running a process, this is what a running state. What happen is, this is what your common section. This is what a user level thread 1, user level thread 2. What happen is, executing CPU. There is a IO operation, or there is any kind of thing that the thread is moving towards the block state. You have one thread. T2 is, let's say T2. Okay, so let's move it to the T2. Let's say that T1 come, the thread T1. Okay, so the thread T1 come, execute. Okay, thread T1 come, execute. Thread T1 come, get a CPU, execute, terminate, and get a result, and it leaves. But thread 2 come to the CPU, whatever happen is it goes to a if it goes to a wait state, or you can say a block state. If a thread 2 goes for a block state, and if there is another thread as well, T3, let's say. So what happens if your one thread, even a one thread goes in a block state, whole process is terminated. Whole process is goes to the blocked state, not terminated. Whole process is goes for a blocked state. Okay, so these things happen in a user level thread. But what happen in a kernel level thread? What happen? Let's say this is one process. It can deal with a process, or you can say thread. Okay, so process 1, process 2, process 3. If there is a fault in a P1 process, P1 goes for a waiting or a block state. Other two process can easily execute. Okay, so this is what happened in a user level thread as compared to a kernel level thread. If the same, because these are doing the same thing. Both the thing are both the processes are doing the same thing. But if one thread is goes to a block state, operating system put everything in a block state. Why? Because operating system doesn't know that there is a T3 thread as well, there is a T4 thread as well. So operating system doesn't know about the user level thread. This is what a quality of a user level thread is. So if operating system doesn't know about a user level thread, then it means if one process is blocked, it treated that the whole process is blocked, because it treated whole as a one. It because operating system treat whole as one. So if one thing is break, one at one thread is goes for a blocked state, everything, whole process is goes to the block state. Operating system put whole process in a blocked state. So this is what happened in a user level thread, and in a kernel level thread, this thing is not happen. Okay. So if it is not go, then it, because it treated whole as a one and it doing so many things, but but the kernel thing, what happened is it treated one thing as a one process, another thing as a one process, another as one process, but it treated whole thing as a one process. So definitely it is fast as compared to this. So this is what after point is fast to create and manage. Fast to create and manage is basically slower to create and manage. Okay, it is slower as compared to the user level thread to create and manage. So this is a user level thread and this is a kernel level thread. Okay, so this is what happened in the multi-threading. I hope you understand the concept of a multi-threading in detail. Okay, so this is all about the multi-threading, about the thread, about this user level thread, kernel level thread, everything about the multi-threading. Okay, so thanks for watching this video. Like the video and subscribe my channel.